So welcome back. We're doing section 6.2, and this is the second part of this video. I broke it up to make this section a little bit easier to be a reference for you. This part here is going to be talking about how to use the normal table in great detail, and these are going to be kind of problems you're going to be seeing again pretty much for the rest of the semester. So this is a really key portion to get under control. So we are going to use the standard normal distribution and the table to find probabilities. So use the histogram to find the probability that a randomly selected woman is less than 58 inches tall. So normally we're just going to be using the tables to do this, but today in this video, we're first going to be talking about how well does this model fit the data. So first we're going to use our data. So our actual data says a woman is less than 58 inches tall. So looking at that, you can see on our graph, we've got that sectioned off, and this histogram is giving us the count of observations that are less than 58 inches, and that's 35 women. And all together, we can add up the 35 women that are less, and we can see over here the 1340 that are more. So all together, we have 1375, and this comes out to be 2.5%. So about 2.5% are fewer than 58 inches tall. Now let's see how to figure this out using the model, and secondly, are these a good match? So here's our model of a normal with a mean 62.5, standard deviation 2.4. So 58 inches is, going to be over here somewhere, and we're wanting to know that this little area under here. In order to do this, since again we can't use like just a rectangle or anything to figure out this area, we're going to use our table to give us the area. So our table only works for the standard normal model. So we need to standardize our score. So let's look at our Z is going to be equal to what we're observing, 58, minus our mean over our standard deviation, and this value comes out to be negative, which we'd expect because we're less than the mean, 1.875. So for us, when we're using our tables, we're always going to be rounding to our 100th digit because that's what our table works to. So negative 1.88. So that's the value that we're going to be looking up and using to find this area or the probability. So this corresponds on the standard normal table to negative 1.88. So that's like here, negative 1.88. So these two areas are the same. We're just lining them up. And now that we're using our standard normal, we can use the table to find this probability. So I'm actually going to flip in here to the back page of your packet so we can look this number up together. Again, this is a crucial part of the skill, knowing where this number comes from. So the probability that Z is less than negative 1.88, that's going to be equal to the probability that X is less than 58. Okay, that's the probability of choosing a woman whose age is less than 58. Height is less than 58, sorry. So let's go ahead and see how to get this probability off the table. Okay, so let me flip to our tables pages, negative 1.88. So that's going to be on our first page of our table. So remember, we start in this column over here. We're looking for negative 1.8, which is right here. And then remember the number we're looking for, negative 1.88. So we've so far done these two digits, and we're still going to look for this 8, the second 8 here. And that's going to be found up along top. The 100th digit is along this top row. And so we come down, and where those two numbers meet, this is the area under the curve. This is the probability of choosing someone whose z-score is less than negative 1.88. So now we're going to try to hop back to our work. Did I get to the right page? Good. So let's scroll down. So we find this is 0.0301. That's 3.01%. Okay, so now we can compare. Remember, our data said the probability was 2.5%. Our model said the probability was 3.01%. So those are pretty good. I feel that's a pretty good estimate. Now let's look at another scenario. So this scenario that we just did to review was a less than. A woman is less than 58 inches tall. Okay, the next scenario we're going to look at says, what's the probability that a randomly selected woman is between 58 and 66 inches? So this is a between. This is a little bit trickier work. A couple more steps with the between. So you can see in our table over here, we've got the markers already done for us, so we can do the data real quick. So there's 1,220 women who are between 58.5 and 66 inches over the same denominator, 1375, and this comes out to be 88.7%. We'd expect it to be pretty big. It's right there in the center of our distribution. So now, how can we do this with our model? Well, we need to always first calculate our z-scores. We have two observed values. We have 58.5. So that's going to be about there. And we have 66. So we need to find a z-score for each of these. So 58.5 minus 62 all over 2.4. Our standard deviation gives us negative 1.67. Again, rounding to the 100th and expecting a negative number because we're less than the mean over here. This one I expect to be positive because I'm going to be greater than the mean. 1.46. So let's mark these on our standard normal. 1.46. That's going to be about there. And what was the other one? Was negative 1.67. Okay. So let me color in a little bit. What we're really interested in is this red area. And so this is our interest to find the red area. But in order to do that, we have to use our table. So if we look up the probability, if we look up this number here, let me use the negative 1.67, our table is going to give us the probability of being over here, which is good. We need to know that. So let's look that up using the table. And you can pause the video and go check your table. 67. And that will be 0.0475. So hopefully you got the right probability for the green area. And if we look up this other z score, the probability of z being less than 1.46, that's going to be equal to 0.9279. Okay, now remember that this one is going to be the area under this, everything to the left, including the green. But since we're only interested in the red, what we can do to find the probability that we're between these two things, 1.46, is to subtract. So we have this big probability, this whole blue area right under all of this over here is 0.9279, but we want to subtract off this little green section because that's not the part that we're interested in, and that we said was 0.0475. And the part that we are interested in, the red area, will be that difference, 0.8804 or 88.04%. Okay, so again, let's assess how we did. Our actual data we found was 88.7%. The model gave us 88.04%. So again, that seems like a pretty good estimate. So we've done less than, we've done between two numbers. Our last one is, last scenario we're going to do here is greater than. So let's use the histogram to find the probability that a randomly selected woman is greater than 69 inches tall. So greater than, we're talking about this area to the right of 69 inches. So again, we can use this count. 6 women fell into that area out of 375. That's 0.0044. And that's about 0.44%. So now coming down here, using our model and our table to find this, Z is equal to 69 minus 62.5, which is, and then we're going to divide that by 2.4. That comes out to 2.71. So remember this time, what was our number? 69. Okay, so we're just looking at this tiny little area over here. This time, we're looking for greater than. So remember that when we look it up on the table, we always get the left side. We get what's over here. Oops, I was trying to make that green. We get what's over here to the left when we look it up on the table. But we are, now it does it. We want what's greater than. So let's color this green because now it's, my thing turned green. Okay, and so the red, if we look it up on the table, we're going to find this number to be 0.9966. The area to the left of this line is 0.9966. We want to know the green area. And if we remember, this whole area is 1. So we can do 1 minus 0.9966, and we find that our area is 0.0034 or 0.34%. So that compares to the 0.44% that we found with the data. Model. Oops. So that's, again, a pretty good model. I'm going to quickly show you on StatCrunch how this can also be accomplished. So if you open up StatCrunch and go to Stat Calculators, Normal, because that's the model we're interested in, and open it. On your homework, you're welcome to use this method to find it, but just be sure that you're also capable of using the table for the test. So you can put in your mean of your distribution. Ours is 62.5. Our standard deviation is 2.4. We wanted to know the probability of being greater than 69 inches tall, and if we compute that, it comes out to being 0.0034, just like what we saw with our model. You could also use the standard normal and make this 0, mean 0, standard deviation 1, and put in your z-score, which we calculated to be 2.71, compute it. Oops, I wrote the wrong thing. Let's try that again, 2.71. And again, it comes out to being 0.0034. You can see this little spot over here is colored in, shaded in. That's the area you're finding. You can even use StatCrunch to find between. So right now it's finding between one standard deviation below and one standard deviation above, which is 68%, which we're not surprised about because our empirical rule says that that's about what we expect. So using StatCrunch, that's how you would do that. Remember that on the test, you have to use the tables. Okay, so I'm going to close this, and we have one last problem. These types of problems are basically a reverse of what we were just doing. So there may be times when we're given that probability or the area, and we want to know what height corresponds to that. So oftentimes we're going to be seeing the word percentile in these types of problems. For example, how short would a woman have to be among the shortest 1%? That's the same as being in the first percentile. So the shortest 1%, I don't know exactly where this line is, but we're talking about some tiny area over here. 1%, they're telling us the area. So we want to know what z-score corresponds with an area that's 0.01. So we can do that by going and looking on the inside of the table. So remember, the outside is my z-score. The inside, these are my areas. So let's look for 0.01. Okay, I'm getting really close. I have 0.012. Let's there. 0.0102 and 0.0099. So this is the closest. So we can use this number. And now we're going to like reverse read my z-score. So I have negative 2.3, and then we go up this way to read the hundredths. So I need another 3. So on your little picture up here, this is negative, I guess my picture could have been more like this, negative 2.33. That's the z-score that corresponds to that. So we're kind of working backwards through the problem. We have one more step. We still want to find the height. So we know that z is equal to our observed height minus our mean over our standard deviation. We know that the z we were interested in is negative 2.33. Our observed height, that's what we're still looking for. We know our mean is 62.5, and our standard deviation is 2.4. So now we have all the pieces except for the height, so we can solve for x by multiplying both sides by the standard deviation. And then adding the mean to both sides, that would give us 56.908 inches. So this video is a good reference for a lot of problems that you'll be seeing. So be sure to come back to it if you get stuck on the table. Again, these tables we'll be using for the rest of the semester, so it's extremely important that you have the table under control. So we have one more video from chapter 6 that'll be coming up.